G'day lads, it's Mr. K here, just doing some powers of powers with you now. So again, it's just still reviewing some of those algebra concepts that we've gone through this term before I go into expanding and factorizing tomorrow morning. So you should pause the video right now and give them all a crack. I've made them, hopefully I've made them all pretty simple. Except for these three, they're a wee bit gnarlier. So I'm just going to get stuck right in. So x squared, all in brackets squared, well that just means that whatever's inside this bracket, we times by itself. So x squared squared, okay? So that just means x squared times x squared times x squared, and what do we get? We get x to the 4 from our previous lesson. So we're going to add those powers together, or what's actually happened is that we've actually multiplied those two, and I'll show you why that's true here with this one. Right, it's not exactly obvious. So we go x cubed multiplied by itself is x cubed. It's just what that power of 2 means, multiplied by itself. And if you were to add those powers, you'd get x to the 6. And we're always looking for shortcuts to get from here to here. And what you'll notice is that from here to here, we can just multiply those two powers. What's quite interesting, however, is when you have a constant or even another variable in there, and we're squaring. So this means 3x cubed times 3x cubed. 3x cubed times by itself once, right? Times by itself squared. Well, you can see that we can get 9. And because order doesn't matter in multiplication, or not at your level at least, or not either, we are going to get x to the 6. And what I want to just draw your attention to there is that that power of 2 distributes across everything inside that bracket, inside the multiplication. And we say that powers are distributive across multiplication. You guys should go ahead and do an addition one and see if powers distribute across addition. So is that the same as 3 squared plus 2 squared? You might find out, might see why it's an important concept of multiplication. So what we can do now, we can skip all of this step. We can cube 2, call that 8. We can multiply our powers on the x's, so we can go x to the 12. So it's not adding anymore because we've got x to the 4 times x to the 4 times x to the 4 times by itself 3 times, and y to the 9. So hopefully you got those 4 correct, or if not, hopefully you can see what's been done now. So now we start to mix things up, and I think division is usually the most powerful way of looking at this. So the first thing we want to do is just expand this bracket out. I might run out of room here, so I might need to get an extra bit of paper, but we're going to get 5 squared, 25, x squared to the power of 2, so that would be multiply the powers, that would be 4, and y to the 6, right? Y to the power of 3 times itself, so y to the 3 times y to the 3 is y to the 6, or just multiply those powers out. Now this is all over 10 x cubed y. Nothing has happened down here. We can now go ahead and just simplify that, so 25 over 10. Well, we can take a 5 out of the top and bottom, right? We're just going back to some of that number skill. So we can say that's 5 over 2. And see how I've just given myself some room to add in some other variables where needed. Now we're going to look at x to the 4 over x cubed. Well, that's going to leave me with 1 x on top. It's just going to be x on top. And here we're going to have y to 6 over y. So we're going to be cancelling down one power, just one power. So that is y to the 5 on top. Awesome, and we're done. Nothing else there can be simplified. Now in the previous video, we talked about the square root being a power of a half, and that is just another power that can distribute along here. So we can do the square root of 16, it's 4. We can multiply powers, just like what we've been doing here, and here, and all over the place. We can still multiply our powers, so we can say that's x to the 4, y to the 2, and this is all over, nothing has happened to the bottom here. It's 2x squared y on the bottom. Awesome. So what times itself gives x to 8? Well, it's x to 4. And what times by itself gives y to 4? Well, it's y to 2. Or think about multiplying those powers, just like we've been doing up here. So 4 over 2 is 2. We've got x to 4 over x squared. Well, it's going to cancel 2 top and bottom, leave me with 2 on the top. And we have a y squared over y, cancelling a y. And there we have it. That's as simple as it gets. That's our answer. Alright, this is a big one. We've got top and bottom, we've got brackets, and we've got a powers to powers, okay? And remember that rule, that this power distributes across multiplication. So we get 4 cubes, that's 4 times 4, which is 16, times 4 is 64. And that's going to be x to the 3. Right, there's x to the 1 there, we don't write the 1, so that's x to the 1 times x to the 3, and we can multiply these powers as well, y to the 9. This is all over, we do the same thing down here. 2 squared, x to the 8, multiplying those powers, and y to the 2. Now all we're doing is cancelling down. I'm looking at my numbers and I say 64 divided by 4 is 16. And I know that because I just worked out 4 times 4 times 4. So I just come back one step. I know I'm going to get 16. Now this is interesting, so I'm definitely going to need a fraction line there. I forget what that line's called. Why don't you guys actually comment below what the line is called in a fraction. This line actually has a particular name. So there's a little bit of homework for you. And we're going to have x cubed over x8, so 3 of those are going to cancel, leaving me with x to the 5 on the bottom, right? If I subtracted those powers, I can have x to the 5 left over once I've cancelled them all out. And this is out the other way, I've got more on top, more y's multiplying on top than on the bottom, and I have y to the 7. Alright, hopefully that makes sense. We have now just covered the distributive property of powers over multiplication. So if we were to write this as a rule, we could say that x, y to any power can be written as x to that power times y to the power. That's a little algebraic definition there. Take any two things, if I raise them to 1 power, it's the same as raising them each to a power and then multiplying. Right, and we call that the distributive property of powers across multiplication. So that distributes across the multiplication. Does it work for addition? I'll leave that for you. Like that smash button.